This is AP Precalculus. We are on the practice test for Unit 1. This is the comprehensive test practice for polynomials and rational functions. In Section 1, Part A, we have 14 questions. You're supposed to spend 40 minutes on this. I know that it says in the instructions that we're supposed to write our answer choices on a separate answer sheet. We're not going to be doing that for the multiple choice. I'm just going to write the answers here, but when we get to the free response, then I will be writing it on a separate sheet. All right, and number 1, which of the following describes the behavior of the graph K from A to B? From A to B, I'm clearly going down, therefore I'm decreasing, so it's not increasing, it's not increasing. I am going down, decreasing, and I'm clearly trying to pull up. I'm trying to pull up, therefore I'm concave up. So this one's going to be concave up, and you can see usually you can write an arrow here, concave down over here. It is indeed concave up. So concave up, correct answer is C. And number 2, the function has the following end behavior. So let's go ahead and interpret our limit. This negative, when I have x is left and right, and negative means left, versus this x over here, which means right. And this is talking about a height. This means I'm going a height that is going down, and this negative infinity also means I'm going down. So if I were to draw a graph, a picture of what's going on, I would say as I go to the left, I'm going down. As I go to the right, I'm going down. So if I want to turn that into a picture, then I can say something looks like this. That would be some sort of picture, right? So because we have end behavior that matches here, whenever there's match, so I'll say here and here is a match, therefore we know it's an even function. If there's a mismatch, maybe if I had something that went like this, that would be an odd. And because our right hand over here, I'll analyze this, our right hand over here is down, that means that we are negative. Again, if our right hand had been up here, then it would have been a positive. So we know it's a negative even. So those are the negatives, and that's the power that's even. So the correct answer here is B. And number 3, we have a hole at x equals 2 and a vertical asymptote at -4. We're trying to find the following. So, I mean, the long way to do this is to factor the top and the bottom and seeing what crosses off to check if there's a hole or not. I think the easier way to solve this problem is to build it ourselves. Make your custom designed function. If we know that we have a hole at x is equal to 2, we know we must have an x minus 2 on the top, and we have an x minus 2 on the bottom. If we have a vertical asymptote, that means we have something in the bottom. This is going to be x. What do we have here? Because we have a -4, this is going to be a positive here. So we're going to say this is +4. And there might be other junk happening here. There's probably some other thing that I don't know here, but I know that the bottom here, I can multiply this out, right? I can say x times x is x squared, x times 4 is 4x, -2 times x is -2x, and -2 times +4 is a -8. So the bottom, the denominator here, should be x squared plus 2x minus 8. So which of these has a denominator of x squared plus 2x minus 8? We're going to ignore the numerator for now. So ignore the numerators. We're only looking at the denominators. And this x squared plus 2x minus 8 is only found right here. So correct answer here is B. If, I guess there might have been multiple x squared plus 2x minus 8s. And in that case, you would need to factor the top and make sure that the top has an x minus 2 still. In number 4, all right, we need an average rate of change. Again, whenever you see those words, we cross it off and we just say we have a slope. A slope of -1/3, and we start at -2. We start at -2, so we start at this point, so this is our start, and then we're going to move to any point that we want. And we're trying to figure out how many times do we cross this this line. Maybe I cross there, maybe I cross there. I don't know, right? So to do that, I'm going to make my slope of -1/3. Remember that if I have a slope of -1/3, this is saying 1 down and 3 right from the point that I'm talking about. So the point I'm talking about right here is my starting. I'm going to go 1 down and 3, 1, 2, 3 to the right, which means I have a point here, 1 down, 3 right, 1 down, 3 right, 1 down, 3 right is going to be probably off the graph, and then I can make a line that connects all of these, and we can see that there are there's an intersection here, 1, 2, 3, 4. There's a total of 4 intersections. So at each of these spots that I've circled, each of those is a point at which the average rate of change, or the slope, is that -1/3. So total of 4. Correct answer here is D. Lead on to number 5. got a table. We're going to see which of these is a correct statement. And sometimes, just as a heads up, sometimes they do the reverse. Which of the following does not best fit the data? So just be careful. All right, what do we have? It's either linear or quadratic. So that's kind of easy to answer kind of right off the bat. Ooh, there is a mistake here that I will change in future years. For some reason, I forgot my negative out front, but there should have been a negative here. My bad. I'll fix that later. That means that I'm increasing by a constant amount. I'm adding 3, I'm adding 3, I'm adding 3, I'm adding 3. So if I have the constant increase in x, then I can just purely analyze the y-coordinates. So how do I move from -6 to 1? I add 7. From 1 to 8, I add 7. From 8 to 15, I add 7. From 15 to 22, I add 7. Because I'm constantly adding 7, this is a linear function, so we know it's linear. It's not quadratic. It's between a and b. And which of these is the correct definition? So there's only a slight difference. One of these says, okay, again, rate of change is just slope. And then the change in the average rates of change. So average rates of change, again, is the slope. So notice what the difference here. This is saying that the slope is constant. This is saying that the change in the slope is constant. So is the change in the slope constant or is the slope constant? We did not analyze the slope here. We just analyzed the first differences. So neither of these are up here. So let's go ahead and calculate the slope. So I'm going to do a new column here. I'm going to title it slope. The slope for each of these is the change in y divided by the change in x. That's the definition of slope all the way back from Algebra 1, right? So our slope here is going to be 7 over 3. Slope is going to be 7 over 3. The slope is 7 over 3. The slope is 7 over 3. So the slope does not change. The slope is constant. It is constantly 7/3. Constant means it doesn't change. So the slope is constant. The correct answer here is A. What is B trying to say? B is saying that the change in the slope is constant, which means if we did the difference between the slopes, and I was adding 1 to get from here to here, I was adding 1 to get from here to here, adding 1 to get from here to here, that would be the change. This 1 is the change in the slope, but the slope is the same amount. If the slope changes by a constant amount, by the way, that would not be a linear, that would be a quadratic. All right, and number 6. We have this equation, and we're trying to find which of the following could be a graph of P. So I'm noticing that the right hand is upward. I like the right hand behavior because it's really easy to do. Right hand is down, 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 up. So we know that this function is a negative function, this is a negative function, this is a negative function, and this is a positive function. And notice the equation up here has a negative up front, which means we have a negative equation. Therefore, the answer is not D. What else do we know? When I'm looking at the differences between all of these, I'm noticing some of these are even, some of these are odd, right? So if this does not match, that's odd. So we know that this one is a negative odd. We know that this one also doesn't match. So this one is a negative odd. But up here, these two do match, which means this is a negative even. We can answer that right now, right? We can multiply the power. This really is a power of 1, and this is a power of 1. So I have, I'm just going to add the power since I'm multiplying the same basis. So 1 plus 2 is 3, plus 1 again is 4. So this one was a negative even, because power of 4 is even. So there's only one negative even, and the correct answer here is A. Another way to look at this is to look at zeros, right? I didn't have to do it this way. I could have used a bunch of different tools. I said, okay, well, every single one of these factors should be a 0. So this should be a 0. I have an x-intercept of 0. Oh, that one didn't have an x-intercept of 0. So that one would have been eliminated because I'm supposed to have a 0. I should have had a positive 3 and a negative 2, positive 3 and a negative 2, positive 3 and a negative 2. I mean, these are not even the same distance apart. That's supposed to be a positive 3 and a negative 2. Again, that one would have been eliminated because that's like a negative 3 and a positive 2. There's a bunch of different ways to analyze this, but again, the correct answer is A. Number 7, we have that polynomial function. We're looking for zeros, so let me underline zeros. So what does it mean to be distinct? Distinct just means a different number, equals a different number. So if I were to set each of these equal to 0 to find the zeros, that's what it means to find the zeros. I can say x plus 2, that quantity cubed, we'll set that equal to 0. We'll search for zeros there. And I'll also set this x squared plus 3 equal to 0. And we'll see what happens, right? So if I take the cube root of this left side, so I'm going to take the cube root, take the cube root. What happens here is I have x plus 2, cube root of 0 is 0. And then I subtract 2 on both sides, and x is equal to negative 2. You'll notice that there is exactly one of those numbers. And there's this difference between a real 0 and a non-real 0. This is a real 0 because it doesn't have an imaginary component. If it had an imaginary component, that would be non-real. So this is one real solution. What about in our equation to the left? So I'm going to subtract 3, so I'm going to get x squared is equal to negative 3, and then I'm going to take the square root of both sides. When I take the square root of a negative, I have an imaginary component that pops out, and I have to have a plus or minus. Every single time that you take the square root, you have to have a plus or a minus, and this negative is becoming an I, and then I have a square root of 3. My phone is telling me to go to sleep. So notice here that we have two answers because we have a plus and a minus, and they are not real because there is an I in this case. So we have one real and two not real. So the correct answer here is C. Just as a note for later problems, non-real zeros always come in even numbers, always comes in pairs. So if it had said like 3 non-real zeros, that would be impossible. It's always like 2, 4, 6, 8, one of those even numbers, right? Number 8. Oh, and just as a side note, I know that some people probably said, oh, there's a power of 3, so don't you have to say like 3 distinct real zeros? And the answer here is that's called multiplicity. The power here is called multiplicity. It doesn't affect if it's a distinct 0 or not. Number 8. Let f be that, g be that, and we're trying to find where that happens. So this g is this g right here, and this f is this f right here. We're just going to plug one into each other. So our g of x is this 3x squared minus x plus 2. So again, I just rewrote the g of x. I'm going to rewrite this sign, this greater than or equal to, and then finally I'm going to rewrite f of x, which in this case is all of this 2x squared minus 3x plus 5. And then I just need to solve this, right? So to do that, I'm going to move all the x squareds onto the same side. I'm noticing that this has the larger x squared. So if I subtract 2x squared, then those are gone. Let's move everything to the left then. That means I'm going to add a 3x to get rid of u, add a 3x, and I'm going to subtract 5 to get rid of u, subtract 5, and then now my left side is a 0, and the right side is a 0, and the left side is an x squared, and a plus 2x, and a minus 3. All right, so from here I can factor this. I can say, oh, this is really the same thing as you can do ninja stars in your head, right? So what numbers multiply to negative 3 and at the same time add to 2? And the answer here is x is going to be plus 3 and x is going to be minus 1. That has to be greater than or equal to 0. When you get to this point after you factor, we make our number line. We say, okay, I have a 0 at negative 3 and I have a 0 at 1. Take a peek at the signs, right? This is, or the powers. The power is 1, power of 1. Ones are odd, which means these do change signs. If they didn't change signs, like a 2, then I would cross that one off and say it doesn't change signs. Okay, now we just need to figure out where we're positive and negative, because again, we're trying to figure out where this side is greater than or equal to 0, where it's positive or equal to 0. So I'm going to do a test point. My favorite point to test is 0, which happens to be right here. So when I plug in 0, what happens? When I plug in a 0 here, I get a positive 3. When I plug in 0 here, I get a negative 1. This one is a positive, this one is a negative. Positive times a negative is a negative. And because each of these changes signs for these zeros, we know that when we do the leapfrog method over here, we're going to get a positive here and a positive here. And again, I was looking for where are we greater than or equal to 0? We're greater than or equal to 0 there, including these 2 points because I am allowed to be equal to, right? So how do I say left of negative 3 and greater than 1? Left of negative 3, greater than 1. The correct answer here is C. Number 9. We have that rational function. Which of the following statements about R is correct? All right, so I'm noticing that all of these choices are talking about asymptotes. So asymptotes are comparing your top-bottom rules. So again, you have 3 possibilities. You have a top that wins. You have a top that loses. Or you have a tie. You can say the top and the bottom tie. So if the top wins, you're going to either get a positive infinity or a negative infinity. If the top loses, then it's going to be a 0. And if the top ties, this is a magic fraction. Again, the magic fraction is a fancy way of saying take the coefficients. Take coefficients. All right, so who wins? Again, all of this stuff is minor because of their smaller powers. All of that stuff is minor, smaller powers. Power of 2 versus power of 1, well, the top wins. So if the top wins, I know that the answer is going to be positive or negative infinity. So it does not have a horizontal asymptote, right? This one is incorrect. It does not have a horizontal asymptote. We'll cross off A. And it's between B, C, and D. So yes, it goes off to infinity, and you can see clearly it goes up to positive infinity at a rate of 3x. But it's asking, well, what is the y-intercept of the slant asymptote? Whenever you see the word slant asymptote, that automatically means you are doing long division, or you are doing the box method. You're doing division. So here's how I set up my box. I'm going to go ahead and go like that. I kind of wanted that to be more of a rectangle, but I'm not the best at drawing, so whoa, fingers are, there we go. Better? Yeah, good enough. And then I'm going to separate this in half. Okay, I'm dividing by x plus 2, so that goes on the left. And then the area goes inside of here. So first I have my 3x squared, so my 3x squared goes inside. And then I'm asked the question, what times x gives me 3x squared? Well, 3x times x gives me 3x squared. And since this is 3x, I multiply 3x by 2 to get this value, and I get 6x. Again, remember that these diagonals are always the same. So if I go ahead and put my black line, say, trying to find the next value, I know that this value here has to be an x. And because these are the only two x's, this number and this number must add up all to this number right here, which is a -1. So 6 plus what number is -1? And the answer here is -7. So finally, I can complete my answer over here. What number times x is -7x? And the answer here is -7, which means my answer is 3x minus 7. 3x minus 7, I'm going to choose answer D. Moving on to number 10. I've got a table. Which of the following is true? And it's talking about the degree of each of these. So degree is talking about the differences. So if all of the second differences are the same, I was supposed to spell differences, are the same. And there's a fancy way to say the same, are constant. If all the second differences are constant, then the degree is 2. And if the third differences are the same, or the fourth differences are the same, or the fifth differences are the same, then that tells you the degree. So that can only work if you have increments that are the same. So it looks like +2, +2, +2, +2, +2. Okay, so I can go ahead and look at the first, second, and third, and et cetera differences. Let's do that. Okay, so the first differences, that's going to be this column in red. So to get from -2 to 7, I add 9. To get from 7 to 6, I subtract 1. From 6 to 1, I subtract 5. To get from 1 to -2, I go down 3. And from -2 to 3, I add 5. So clearly this was not degree 1, which wasn't even an option because none of these were the same. So let's go ahead and look at these second differences. So for the second differences, to get from 9 to -1, I go down 10. To get from -1 to -5, I go down 4. To get from -5 to -3, I go up 2. And to get from -3 to 5, I go up 8. Okay, clearly the least possible degree is not 2 because these are not the same for the second differences. Let's check the third differences. So the third difference is to get from -10 to 4, I go up 6. To get from -4 to 2, I go up 6. To get from 2 to 8, I go up 6. And because all of these are the same number, the answer here is the least possible degree is 3 because the third differences are all constant. They are all the same number. The correct answer here is B. Number 11, we've got m and n. And we're trying to get n by transformations. Okay, so there's our m. Let's see what's going on here. First and foremost, we have, I'm going to go ahead and rewrite this. So n of x is going to be equal to, there's an m with some parentheses, and I gave myself plenty of room. First, we have a horizontal dilation. Okay, the word dilation here. Actually, there's two words here that are super important. I'm going to do them each at their own time. Horizontal. Horizontal means that I'm inside the parentheses, and dilation means that I am multiplying. So I'm inside and I'm multiplying. So there's going to be an x right here, and I'm going to be talking about this number that's being multiplied by x. And that number is, you'd normally think it's 3 because it says 3 right here, but because everything that's inside the parentheses is always like the opposite, it's always inverted, it's really 1/3. All right, next we have a horizontal translation. So horizontal, again, means I'm dealing with the x component, which means I'm still inside of the parentheses. And translation means I'm adding or subtracting. So again, I'm inside, which means I need another set of parentheses. And I'm going to translate by -2, but it's opposite. Everything inside the parentheses is opposite, so I'm going to add 2. All right, next we have a reflection. The word reflection always means I'm going to have some sort of negative. And you have to be super careful about this. Over the y-axis, I always draw these out. So if I'm reflecting over the y-axis, let me go ahead and draw an x and y coordinate plane. So if I'm going over the y-axis, that means I'm reflecting from here to here, right? Or vice versa. What is changing? Is the x-coordinate or the y-coordinate changing? The x-coordinate here was like -1, and then it changes to a +1. Therefore, the x-coordinates change. If the x-coordinates change, that's on the inside. The y-coordinates are on the outside. Again, y-coordinates mean vertical, x is the horizontal. So because the x dimension, what am I thinking of? The x-coordinate, there you go. The x-coordinate is changing. It is a horizontal change, therefore it's inside. The negative belongs inside. And then, oh, that's it. So let's go ahead and find, that looks like B. Excellent. Moving on to number 12. The graph of f is shown with 6 points A, B, C, D, E, and F labeled. What are the points where the graph of f has a local minimum? So it has a local minimum. Again, local, I need to analyze these words. Local means multiple, right? There can be as many as you want, multiple. And minimum means you're going to, like if you roll the ball down a hill, where would it naturally settle? It would settle here at B. So I'm going to go ahead and say that's a local minimum, that's a local minimum. And again, it would roll right here and then we'd stop, right? So the ball would end at F. So B, D, and F are correct. Those are the local minimum. If it was an absolute minimum, then it would be whichever one is the lowest of all of those lows. Or if it was an absolute maximum, it's what is the most top of all the tops, right? All right. Number 13, G must be a polynomial whose graph has a point of inflection. Okay, so there's this word inflection. Which of the following statements about G must be true? So in my way of defining the inflection for this class is it's a change in concavity. So if it's a change in concavity, let's go ahead and I'm going to make up a random graph, right? So if I have some graph that goes like this, where I'm concave down and then I'm concave up, somewhere in between there, I change concavity. This is the inflection point right here, the change between concave down to concave up. So which of the following must be true? So you have to have a relative extremum. A relative extremum, just to define these words to make sure we know what we're talking about, that can be either a minimum or it can be a maximum. Extremum is just a fancy word that means minimum or maximum. Relative is a word that means it can be it doesn't necessarily have to be the most extreme. It's not the absolute. It can be any min or any max. So if I'm just taking a peek at this picture, does that look like a minimum or a maximum? Well, no, that looks like a maximum. That looks like a minimum. That is neither of them. So A doesn't make any sense. What about B? The graph of G is tangent to the x-axis. So tangent just means the same slope. So don't worry about that word. So I have the same slope as the x-axis. Well, that's the y-axis, that's the x-axis. So if I'm the same slope as the x-axis, I have a horizontal line. This is a very, very fancy way of saying I have a horizontal line at 3. Well, right here, this line is clearly going down a little bit in my example, so it's not necessarily a horizontal tangent. So it's not B. What about C? The graph of the rate of change. Okay, so I don't like the words rate of change. I'm just going to change it to slope. And I don't like the word rate of change. I'm going to change it to the word slope. So if we graphed slope, that has a relative extremum. Or if we graph slope, that crosses the x-axis. I am not sure. So let's go ahead and convert this graph right here into a graph of the slope. So I'm going to go ahead and say this is our actual graph, and this is our slope graph. So on my slope graph, let me go ahead and graph right here. I'm going to go ahead and just put random coordinates right here. So, or a coordinate plane. So at this spot, I'm just going to randomly choose right here. the slope is 0, which means the height over here is 0. What about over here? The slope over here is clearly going up, therefore it's positive, therefore I should have a positive height. And what about this point right here? Well, now the slope is slightly negative, right? So if the slope is negative, that means I'm down beneath the x-axis. Eventually, we get this slope of 0 over here. So we have to have a slope of 0 somewhere over here. And then eventually, after we have this slope of 0, the slope becomes positive. I'm going up, therefore this, the point up here is positive, which means what we really have is something that goes like that. So where is this inflection point? So this inflection point on this graph, where does that happen? Well, it happens right here. It happens at the minimum of this graph. So the minimum of this graph of slope is the inflection point. So again, relative extremum, I already defined that. It's a minimum or a maximum. In this case, it is a minimum. It could have been a maximum if I had drawn this graph differently, but it is a relative extremum. So the correct answer here is C. Why is the correct answer not D? Does it cross the x-axis? It crosses the x-axis here and here, and those correspond to the maximum or the minimum on the normal graph. But on the slope graph, those are just x-intercepts. So it's not D. All right, number 14. The function R is given by that rational function. What is the domain? So you'll notice that all of these answers down here are say where x is not equal to those things. We're just essentially searching for all the bad things. There's only two things that are really bad in math: taking the square root of a negative, there's no square root, so you don't have to worry about it, and dividing by 0. We have some division happening here. So if this bottom is dividing by 0, if this bottom is 0, that's bad. So let's go ahead and search for those bad things. I'm going to go ahead and say, okay, take that bottom, take this x cubed plus 10x squared plus 16x, and set this thing equal to 0 and see where those bad values are. So we need to factor, of course. So I can factor out the greatest common factor of x, leaving behind an x squared plus 10x plus 16. And then I can factor yet again. Ninja star this one in your head. Again, you're looking for two values that multiply to 16 and add to 10. So multiply to 16, that would be 1 and 16. No. 2 and 8? Yes. So it's going to be 2 and 8. So what are all the bad things? Bad things, this one could be 0. This one could be -2, and this one could be -8. All of those would give you a 0. So those answers, 0, 2, and -8. So there's the correct answer, C. All right, in this next section, we have 20 minutes to get through all of this, and we have a calculator. So let's go ahead and bring our calculator up. I'm using the Calculate 84, which is kind of close to the calculator that you'll be using. You can see that I have stuff written on here. So what I want to do is I want to clear the memory. The quickest way to do that is you see above the plus sign, there's a memory button. So I'm going to hit second plus to do the memory, and then 7, 1, 2. So everything has been cleared on the calculator. There's no old data. All right, I'm ready to start reading number 15. Number 15, the function, that thing has an absolute extremum. Absolute extremum. That means it is a, again, the word extremum can be a minimum or it can be a maximum. An absolute meaning it is the most max or the most min. There's only one king, one queen to rule them all, right? So I need to graph this thing. I'm going to go to my y equal in the top left. And I'm going to type this in correctly, hopefully, 1.1, x to the power of 3. Power is the caret symbol above the division symbol, and that's the power of 3. I'm going to hit the right arrow key so I don't keep typing up there by accident. Minus 8.4 x squared, and then plus 7.9 x plus 5.8. Okay, I have it all typed in correctly, and I can just check. Yes, all right, that looks good. And I want to graph this thing. So I'm going to go to my window to the right of the y equal to button. And my window here, it clearly says, is between -1 and 7. So I'm going to come up here and say that this is -1. Come down here and say that's 7. And then I'm going to zoom 0 this thing to graph it. So there it is. It zoomed out just a peak, just a little bit. And so I'm looking for the highest or the lowest point. So I can see, and I can't draw on the calculator, which is kind of a shame. So what I'm going to do is I'm going to take a screenshot, and I'm going to just grab this graph so I can talk about it. So I'm going to say done, copy and delete. And if I paste in here, I can now draw on top of this, allow full access, sure. So is this, it's kind of small, but we can still talk about it, right? So what I'm seeing here on this graph is there's two things, right? And I should probably be drawing like a light color. This is the most minimum, although this is kind of a close second. And then this is the most maximum. So this is my absolute minimum down here, and my absolute maximum is up here. Those are the two values that I'm seeing. While this one was a really close second, it was a little bit like this one is clearly superior for the absolute minimum. So I want to find, let's go ahead and find the absolute max, because I know that's easy. It's the very end interval, it's at 7. So I'm going to do a second trace to do a calculation of, I guess I just need to do a value, don't I? I don't really need to do it this way. What is the value at 7? Hit enter, and it says, at 7, I have 26.8. So the answer here, one valid answer, is 26.8. That is an absolute extremum. Is that anywhere over here? Darn, okay, none of those are 26.8. That would have been the answer. That means it's probably talking about this value down here, the absolute minimum. So how do I find that? That's going to be a second trace to do a calculation of the minimum. So I'm going to hit 3. Okay, my left bound, I'm looking at my graph over here on the left. So I'm going to say my left bound is 3. So we're going to go 3. And my right boundary, 5 should be okay. So I'm going to do 5. And it says, okay, the answer is at x is equal to 4.56, the y value is negative 28.54. So negative 28.542. Hey, there it is. Okay, negative 28.542. So that was the height. And you'll notice, but Mr. Sindel, it said 4.567. It says it right there on the left, 4.567. Isn't that the answer? That's the x-coordinate where that happens, but it's not the minimum. The minimum is the height. It's asking for a height here. All right, number 16. We've got some data, and it says it's the number of cars available for sale in a used car dealership. Okay, oh, it's a quartic regression to model that data. And then once we get that data, then we have to figure out what is the 28th point, like predict v of 28. Okay, so we need to enter this in the table. So I'm going to go to stat, and I'm going to edit that and start entering data. 2, 8, 12, 19, 24, okay. And then I'm going to come to my list 2 and do 65, 55, 44, 38, and 45. Okay, so I have the data entered. I'm going to go back to stat and go to the right to do a calculation, and I want to do a quartic regression, so it's going to be 7. And I'm going to store the answer in alpha trace y1 and go. Okay, so I have all these numbers. You can compare against me to make sure you got it right. And now, because I have that in my y1, here, there it is, right? Right, second mode to get out of that. So I have it in y1. What I'm going to do now is call y1. I'm going to hit alpha trace y1. I'm going to call y1 and do my parentheses and say plug in 28. And I get 49.835. 49.838. That's exactly B. All right, number 17. Let k be a polynomial given by that thing. Based on the model, how many points of inflection does the graph have? Okay, so just remember, inflection is a change in concavity. Change in concavity. The troubling thing about this problem is I have no idea what my window should be. So I'm going to go ahead and just graph this and guess and then narrow down the window. So I'm going to go to my y equals button. I'm going to clear out that function and type in negative 1.09 x to the power of 4. My goodness. Okay, right arrow key, so I'm not in the power. Plus 1.21 x to the power of 3, right arrow key. And plus 4.13x squared. Okay, so I have my equation entered. Now I have to figure out what my window is. I don't know. I'm going to try negative 10 to 10. That's the default window. Negative 10 to 10. And I'm going to zoom 0 this thing and see. That was way too big. You can see by the y-axis, it goes down to negative 18,000. So let's zoom in to from negative 4 to 4. Let's try that. So let's do the window. You can see that zoomed out a little bit for me. From negative 4 to 4, and I'm going to zoom 0 that. Still zoomed out too far. Okay, I think the important things are happening around between negative 2 and 3. So let's do window again. From negative 2 to 3. And then I'm going to zoom 0 that. Okay, now it's pretty clear what's going on. So again, I think for this one to explain it properly, I need to screenshot so I can look at this, and I'm gonna hit done, copy and delete, and I can paste it in here. So in this graph right here, you can see, let's go ahead and draw, this is clearly concave down, concave up, and concave down. There's only 3 concavities, which means there are 2 changes. There's a change of inflection there and there, more or less. So there's 2 inflection points. The correct answer here is 2 inflection points. And I guess I should leave that in the right spot. So I'm going to leave all of this down here. Oh, didn't mean to make 2 of you. No, why? Okay, there we go. Number 18. We have the graph above, and we're transforming it with this equation down here. Okay, so we need to analyze how this moves everything. So when we have a -3 on the inside, that means I'm going to go right 3. And then the -2, the negative means reflect over the x-axis, but you can just say multiply height, aka y-coordinate, by -2, and then finally go up 1. Okay, so let's go ahead and do that. We can follow around any point we want. We can do that point, that point, that point, that point. I don't know. Let's just do the first point. Okay, so this point starts at -3, 2. So I'm just going to do this with my laser pointer. Which of these do I do first? You always do the inside first. So the inside, I go right 3. So this point is going to go right 1, 2, 3. So I'm living right here. Now what do? Now that I'm living here, I'm going to multiply the height by -2. I had a height of 2. If I multiply 2 by -2, it turns into a -4. Okay, so now I'm living down here, and then I'm going to go up 1. I'm going to go up 1. Okay, I should have a point right here at 0, -3. Any of these graphs have a 0, -3? No, yes, no, no. I mean, I'm pretty sure the answer is going to be B then. Just to double check, though, let's go ahead and do another point. I really like this one. It's kind of a telling, it's like that turnaround spot. So let's go ahead and follow you around. So again, I'm going to go right 3. So I'm going to go 1, 2, 3. So now I'm living here. And then I'm going to go multiply the height by -2. My height was -1, and it's going to multiply by -2, which is now +2. So I'm going to move up here. So now I have a point up here. And I'm going to go up 1. So I'm going to go up 1 again. And I have this point at 5, 3. And at 5, 3, that is the turnaround spot. The correct answer is definitely B. All right. Moving on to number 19. All right, starting at t equals 0 minutes, a copy machine makes copies at a constant rate of 20 pages per minute. Okay, so there's a bit of information there that I want to make sure that we understand. Constant rate of 20 means I'm doing 20 every minute. Next minute 20, next minute 20, next minute 20. So it's like 20 times t. So if I'm looking down at these equations, 20 times t, 20 times t, 20 times t, 20 times t, makes sense so far. Okay. 3 minutes after the first copy machine, which is probably why we have a 3 right there. A second copy machine makes copies at a constant rate of 60. Okay, well, now how fast are we making copies with this 20 and the 60 together? We should be doing 80, which is probably the reason that I'm seeing 80 down here. I don't know which one of those is correct. Both copy machines continue to make copies at their respective constant rates until time is equal to 7, which matches up with all of that. Good. Which of the following is an appropriate model? All right, well, obviously I can ignore the 20t since those are all the same. The bounds over here are all the same. The only difference is these second equations. So to explain this a little bit better, I'm going to do it with a graph, and then I can move from the graph to the equation. Essentially what I have, and this is definitely not to scale, I have something that looks like this. I have some like very slow rate that's going at like 20, and that's like 1, 2, 3, and then at 3, all of a sudden, then it goes way faster, right? So it goes way faster, and then that goes all the way to 7, which I'm not going to draw it out that far. So that's this key point here is happening, and that's at time is equal to 3. And you'll notice that we know the equation of this line. That line's equation is 20t because it says so in all of these multiple choice questions. The question is, what is the equation of this line right here? Because if we have that equation, then we're done. So I'm noticing that this equation can be made using point-slope form. If you know point-slope form, congratulations, you're basically done with the problem. Point-slope form looks like this. You do y is equal to the y-coordinate plus the slope times x minus the x coordinate. And we already know the slope. The slope in this case for this line is 80 because that's the rate that it produces at. That's why we have so many 80s in all those problems. It's going to be x minus a number, and then it's y is equal to another number. So this y coordinate, this x coordinate, are this point. I mean, it could be that point, that point, that point, any point that you have data on. I have data on this point. This point right here, I know it happens at x is equal to 3, so I know I have to have a 3 in here. The problem is, what is the y coordinate? The y coordinate here, if it's 0, it could be that. If it's something else like 60, it could be that. It's between b and c right now. So to find this y coordinate, well, how many copies have been made? Think about it, right? My copies, I've been making 20 copies per minute for 3 minutes. So if I plug 3 into t, it's going to be 20 times 3, which is 60. I've made 60 copies. So this point right here is at the time that I'm making 60 copies. I can say 60 copies. So the correct answer here is B. And just as a more intuitive approach to this, you'll know that like if I were to continue this line down here, I should have a y-intercept that's negative. This y-intercept that's positive doesn't make sense. This y-intercept of not having anything doesn't make sense. This should be down here somewhere. All right, let's move on to number 20, which is the last multiple choice question of the practice test. We have this disgusting rational function, and we're looking for a hole. Here's the problem. Calculators, Desmos, your scientific calculator, like any sort of graphing calculator is terrible at finding holes. They kind of just like skip over and expect you to be like, just don't plug that number in, right? Here is a way to do this. A hole is whenever you have something like an x minus 1 with blah, blah, blah all over an x minus 1 with other blah, 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 right? Because if these two cancel out, that is the definition of a hole. How does that help us? Well, I happen to know a fancy way to break up any sort of polynomial into this form using a calculator. It's with a graph. Because I know that if I have something like x, and I want to write this down without a laser pointer, x minus 1 times x plus 3, this type of graph will look like this. I will have a graph with an x-intercept at 1 and an x-intercept over here at -3. And I'll like cross through the axis. Maybe, I guess if I'm drawing this one correctly, it'll look something like this, right? Ooh, that was not very good. Better, but still not the best. I'll have x-intercepts. X-intercepts here, you do the opposite number to get the factorization. So essentially what we're boiling this down is graph that equation, find where the x-intercepts are to break it apart. Graph that one, and then find where its x-intercepts are, and then wherever you have an x-intercept that there's like maybe an x-intercept that crosses like that and that, wherever there's two x-intercepts, that means I have the same number on the top and the same number on the bottom, therefore I have a hole. I don't know if this is the best way of solving this problem, but it's my favorite way, and I don't know of a second way to do this very easily. So here we go. I'm going to go back to my y equal 2 button on my calculator, clear out of that, and I'm going to enter the 2.5x to the power of 2 on the top, plus 9.1x minus 5.8. Okay, the bottom, I have 1.37x squared, and you'll notice I'm not entering everything into one equation. I want to graph these separately. X squared minus 4.81x plus, wow, very specific, 2.242. All right, what is my window going to be? And you'll notice over here, my window is probably between like -5 to 3 is probably fine. I'll just go to 4. So -5 to 4 is perfectly fine. So say -5 to 4. And I'm going to zoom 0 this thing. And there we go. I knew it was going to happen, right? So we had two x-intercepts. I'll come back up here. Hit done. Copy and delete. And paste it back over here. We had two x-intercepts, as I predicted. And those two x-intercepts happened at this value. So here's the answer. The answer is that spot right there is where we have a hole on our function. And that value happened right about there, which is a little bit less than 1. So what's a number that's a little bit less than 1 but positive? That's got to be C, 0.553. If you wanted to find that value exactly, you could do that by going second trace and you calculate a 0, so 2, and you'll say the left bound is, I don't know, -1, and the right bound is like 2. And it says, yep, the zero's at 0.553, which is exactly what we chose in part C. Excellent. All right, well, that is the multiple choice, and now it's time to move on to the free response. This free response is going to be tricky because I need to somehow see these problems, see my calculator, and see the place where I respond to them. I don't know if I can split my screen up into 3 different pieces. I don't think I can. So I'm going to do a new window here. And I'm going to also open up the same thing that I'm looking at here, and then I'm going to go to the response section. And let's see if I can do this. So if I switch this to the left split, can I, if I close that and then split this, here, let me try this. Oh, I see. As soon as you hit the split view, that tab opens up. You hit split view, and then there's this other thing, right? Interesting. So if I hit here, split view with, I'm just going to hit this again. There we go. So this is how I'm going to start it off. All right. So in number 1, part A, or I guess number 1, let's read what we have. We have a piecewise function defined by 3 linear segments shown in the figure above, and we have another function that is that rational expression. So what I'm understanding from this is f is this graph, g is this equation. Okay, so far so good. H, you mix together g and f. You plug f into g. We're plugging this graph into an equation, which is difficult, but we can do it. It says find the value of h of -1. Okay, well, we can do that. So to find h of -1, what we do is we just rewrite it out. We can say that this is g of f of -1. And we know that f of -1 is found by looking at the graph of f. And up here, the graph of f is shown for us, which is kind of nice. If I go to -1, I get up to this height of 4. So that means that that value was 4. So this evaluates to g of 4. And g of 4 is just an equation that I can enter in, right? G of 4 is equal to, and I can say that this is -2x squared plus 10x plus 3. All of this divided by x plus 3. All this x's is 4s, 4s, and 4s. And I can simplify this. I can say this is going to be equal to -2 times 16 plus 40 plus 3. All of that divided by 7. That's going to be, do I have enough room here? I'm going to go ahead and move this over a little bit. I'm going to say this is going to be moved over. There we go. And I can keep going and say that this is going to be equal to -32 plus 43 all over 7. That's going to be 9 over 7. Is that correct? No, 11 over 7. Sorry, 11 over 7. And there's my final answer, 11 over 7. All right, now I'm on to part 2. Find the value of f inverse of -2. F inverse of -2. Okay, so f inverse is just a fancy way of saying go backwards. So normally I plug in a value of x, like -1, and I get out a height. Now it's telling me, hey, this is a height, I want the x coordinate. So where do we have height of -2? If I come back up to my graph, a height of -2 is right here. A height of -2 is this point, which has an x coordinate of 4. Done. There it is. So we just say that f inverse of -2 is the x coordinate 4. Easy peasy. All right. Moving on to part B. Find all zeros of g of x. Okay. So to find zeros of g of x, I literally just set the numerator equal to 0. So g of x, you can see over here, is this equation. To find the zeros, though, zeros just mean I'm setting the top equal to 0, not the bottom, just the top. So I'm going to say here that -2x squared plus 10x plus 3 is set equal to 0. And we can just solve this, right? I guess we could use the quadratic formula. How would I do this? I don't know if I have the ability to use a calculator, but it was unclear on the practice test or in the real test. I'm going to go ahead and say sure. If you know how to use a calculator, go for it. I am going to use a calculator. Let's do it. Okay, so I'm going to change. Can I move you to a? I wanted my new window to be a calculator though. So I want my new window to be a calculator. And here's how you find this. You're going to go to your y equal. You're going to clear out of everything that we were using before. And we're going to type in negative 2x squared plus 10x plus 3. And we're going to just graph this thing. So I'm going to zoom 0 and see if... all right, well, we have two different spots. I'm going to change our window here from negative 4 to positive 6, because I think that'll be better. Zoom 0. All right, those are where we have our zeros. So I guess I could have used the quadratic formula over here, but I just wanted to use a graphing calculator to show you how you do this. So I'm going to do second trace to do a calculation of a 0, which is going to be 2. And my left bound is going to be, I don't know, like negative 4. And my right boundary is going to be 0. And it says I have a 0 at a negative 0.284. That's one of them. And the other 0 is where I have another x-intercept. It looks like about 5. So I'm going to do a second trace, another 0. And my left boundary is going to be 4. My right boundary is going to be 6. And it's about 5.284. Cool. How would you do this if you did not have a calculator? You just do or quadratic formula, which is x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. And you just say that a is equal to your negative 2, b is equal to your 10, and c is equal to your 3. Plug it into the quadratic formula, and I don't think you'll get a decimal approximation because you don't have a calculator. You can just leave whatever you get like that. All right, what about part 2? So this is the trouble with going back and forth between a calculator. I want to do a split view with myself. Oh, it came up as an option there. All right. Switch like that and come back over here. All right, so we're on B, part 2. Determine the end behavior of g as x decreases without bound. Okay, well, that's kind of straightforward. So as x decreases without bound, so that's a limit notation. So we're going to say the limit as x approaches what? It says decreases, right? Decreases without bound. So decreases means I'm going negative infinity of my g of x function. Okay, so when I plug in negative infinity, that means essentially I'm going to come in here and I'm going to say none of that matters, none of that matters, none of that matters. Essentially, I have a negative 2x squared over x. So I'm going to say this is negative 2x squared over x, and then plug in infinity. I mean, it's not technically correct to say that, but it's a useful lie. Can I get some colors here? Thank you. So we're going to plug in negative infinity, plug in negative infinity. I only really care about the signs, guys. So really what's going on here, I know the top wins, for sure. 2 beats 1 every single time. The problem is I don't know if this is a positive infinity or is it a negative infinity, right? That's the question. Is it positive or negative? Top definitely wins, though. So notice that whenever I have a number squared, it's always going to become positive. So this piece right here is positive, and this piece right here is negative because it's negative 2, and this piece down here is negative. So on the top, a negative times a positive is a negative, bottom is a negative, therefore the answer here is a positive infinity. We knew the answer was either positive or negative infinity. In this case, it's a positive infinity. Excellent. All right. What about for 1c? So coming down here, determine if an inverse function of f can be constructed on all the domains of f. Okay, so inverse function just means I'm going backwards, right? So normally what happens is you give me any x coordinate you want. You give me negative 2, I'll tell you negative 2 has a height of 4. You tell me 2, that has a height of 2. There's no confusion whenever you tell me an x coordinate. If I'm going backwards, instead of asking what height at this x coordinate, I'm saying what is the x coordinate at this height. So going backwards, what if I say, what's the x coordinate when I have a height of 1? Well, it could be here or it could be here, which is a problem because I don't know which one I'm referring to. What if I have, if I choose 4, what x coordinate has a height of 4? Well, this has a height of 4, this has a height of 4, this has a height of 4. There's literally an infinite number of points that have a height of 4. it's a problem. So normally a function has to be a function by passing the vertical line test. To be invertible, to be an inverse function, you have to pass the horizontal line test. It does not pass. It fails here, fails here, fails here, fails here. I mean, it passes over here. But even if it fails once, it's done. And it failed an infinite number of times right there. So this one is not invertible. So we'll say not invertible. What is this question asking exactly? Determine if an inverse function can be constructed. No. Okay. Part B, or part C2. Give a reason for your answer based on the definition of a function. So a function, we'll say you can say it this way, it fails the horizontal line test. That's kind of an easy one. Or you can say it has multiple we don't want to say multiple heights we want to say multiple x coordinates for one y coordinate, which is kind of what I was saying earlier, right? Give me one y coordinate. In this case, I gave you a y coordinate of 3, and that had multiple x coordinates here and here, right? All right, and we're on to the last multiple choice, or the last free response question. I'm realizing as I'm recording this video now, every single one of these did not require a calculator. I mean, I used a calculator to jump really quickly to here, but I could have just plugged into here, and everything else never used a calculator. I'm pretty sure we are not supposed to use a calculator, which makes me feel, number 2, there's no calculator. All right, let's read. Number 2, in a large town, the local cable company experienced a service outage that prevented residents of the town from being able to watch their local football team play on television. As the local cable company began receiving phone calls to report the outage, residents were placed on hold while operators attempted to respond to the customers' calls. The number of customers on hold with the cable company is given in the table above with selected times following the service outage. Okay. So, and it also tells us that the number of customers on hold 2 minutes after the service outage can be modeled by the function c given by this thing. Okay, so I'm noticing when I'm looking at this equation that the highest degree is power of 2, which means this is a quadratic function. If it was a power of 3, it would have been a cubic function. If it didn't have any powers at all, and it was just like a power of t, or t to the power of 1, would have been linear, right? Interesting. So let's read part A1. So use the given data to write 3 equations that can be used to find the values for constants a, b, and c in the expression for c. Okay, well, this is a really hard problem because you're not supposed to use a calculator here. If I had a calculator, I would just do it. I'll show you how to do it on the calculator in a sec here, but this is how you set this problem up. Part 2 is scaring me. Here we go. This is how you set this up. We know that my function in general looks like this. I wanted to move you over a little bit. I can erase that line over there. Weep. All right. In general, I have a function that looks like this. C of t is equal to at squared plus bt plus c. I know if I plug in a t value of 3 to each of these t's and these t's, that's what happens. If I plug in 3, I'm going to get a times 3 squared plus b times 3 plus c. Then the output, the y value, the c of t value, when I plug in 3, is 11. That means that 11 comes back over here. Is 11. All right. So that's one of the equations. I mean, I can simplify this a little bit, but not by much. I can say that 11 is equal to 9a plus 3b plus c. Cool. And then give me another equation. Okay, well, I used this point and this point. The next equation comes from those two. I assume you know how to do this by now. But let's go ahead and write this. I'm going to look at the table over here so I can see what's going on. I'm going to say that if I have 10, what was it? It was a, right? Yeah, so if I'm going to say 10, so a times 10 squared plus b times 10 plus c will have an output of 32. There's my second equation. And my third equation, if I have a 15 squared, that's my a times 15 squared plus b times 15 plus c, I'll get an output of 28. Those are my three equations. I'm going to simplify these because I'm going to have to use them, unfortunately. This is going to be 32 is equal to 10 squared times a is 100a plus 10b plus c. Over here, I'm going to get a 28 is equal to 15 squared is 225a plus 15b plus c. So, cool, I have three equations. Part 2 over here is saying, now find the values for a, b, and c. I'll be real with you guys. It's kind of a pain to do this, but I'm going to show you how to do it just using your brain, a pencil, and some paper, no calculator. And then we'll come back and check this with a calculator. This is going to be a tedious process, and I'm just trying to be upfront about it. So we're going to mix these equations. So I'm going to color code these so that you can keep track of what the heck I'm doing. So I'm going to say, you guys are the, oops, I didn't mean to copy. You guys are the color blue. You guys, oh, not all of that. You guys are the color black. So now you can see where the equations are. So I'm going to combine the red and blue equations to get rid of a variable. I can get rid of the c pretty easily. Watch me. I'm going to say 32 is equal to 100a plus 10b plus c. I just rewrote it. I'm going to rewrite the red equation. 11 is equal to 9a plus 3b plus c. If I combine these equations, and I'm going to do that with subtraction, 32 minus 11 is 21. 11a or 100a minus 9a is 81a, and 10b minus 3b is 7b, and c minus c cancel each other out, which was the entire point of this process. I can combine two equations to go down a variable. I can do the same thing. As long as I don't choose blue and red, I can choose any two equations to get rid of a variable. Because they all have a c in it, it's kind of easy. So I'm going to choose blue and black for simpler, just to make it easy. So I'm going to say 28 is equal to 225a plus 15b plus c. And that's going to be, I'm going to combine it with blue. So I'm going to say 32 is equal to 100a plus 10b plus c. And I'm going to subtract these in a different color. So if I subtract these, 28 minus 32 is a negative 4. 225a minus 100a is 125a. And 15b minus 10b is a 5b. And c minus c cancel each other out. So look at what I've done. I have gone from 3 equations with 3 variables into 2 equations, each with 2 variables. Making progress, right? Now I have to go a step further, and I have to combine these 2 equations into 1 equation. So I need to eliminate a variable. Do I want to eliminate that a or that b? I mean, I have no idea what the common factor of 81 and 125 is. Those are gigantic. Let's eliminate the b's. Those are easy. So to make sure that this b and this b are the same number, see how those were the same number, I'm going to multiply this 7 by that 5 and this 5 by that 7. They will be the same number. We might as well throw in a negative to one of them to make sure that they come out nice. So watch me go. I'm going to say this entire equation, let's multiply by negative 5. This entire equation, let's multiply by 7. What's our new equation going to be? Down here, I'm going to get negative 105 is equal to 5 times 81 is 405, but there's a negative. Negative 405a minus 35b. Okay, what about over here? I'm going to get a negative 28 is equal to 7 times 125. That's going to be 875a plus 35b. Cool, so I set up my equations such that if I just add them together, this negative 35b and this positive 35b will cancel each other out. So what I'm going to do here is I'm going to grab you, not the parentheses, just you, and I'm going to copy you, and I'm going to paste, what? That's not right. I'm going to grab you, I'm going to copy you, and then paste, there we go, paste there. So watch what happens if I add these straight through. If I add them straight through, I'm going to be getting rid of the b's, which was the whole point. Okay, how many a's do I have? I have 470 a's. And how many do I have on the left? I have a negative 133. Cool. And then I just divide both sides by 470. Just want to double check that math. Yeah, 470. And I'm going to get a is equal to negative 133 over 470. I have chosen a terrible problem, and I think I'm going to probably redo this in future years because that is disgusting. I think the actual test, this comes out really nice to like 2 or 3 or 0, right? So what does this mean? This means that I've been searching for this equation, right? This equation, I now know what A is. I'm just missing the B and the C. Once I find B and C, I'm done. I found A. It's this disgusting fraction. So how do we solve for the next variable? Well, check it out. I have an equation right here and right here that if I plug in an A, I'm left to find the B. If I plug in an A, I'm left to find the B. This one is smaller, so I'm going to use that one. So here we go. I'm going to rewrite that, and I'm going to say I have a 21 is equal to 81A plus 7B. And this is disgusting. Negative 133 over 470. To multiply, okay. This is a bad problem because this should have been easier. I unfortunately do have to use a calculator, so I'm going to come back here. And the whole point here is to not use a calculator, and yet I'm using a calculator for these calculations. Kind of silly. So I'm just going to do what is negative 133 divided by 470. And then I'm going to multiply that by 81. I'm using decimals. So this is going to be equal to negative 22.921 plus 7b is equal to 21. Okay, then I'm going to add 22.921 to both sides. So I can do 21 minus that negative, minus my answer. And I get, if I add that 22 to both sides, I get 43.921 is equal to 7b. And then finally divide both sides by 7, divide by 7. And I get, I don't think that's right. I think it's supposed to be like 7.11. I think I must have messed up somewhere. Don't know where it was that I messed up. 875. Is that right? I have a sinking suspicion that you are wrong. 7 times u. That's right. Was I messing up here? 5 times 8 is 400. Don't know what the mistake is. I'm looking through here. I'm pretty sure negative 133 is right. .470. Oh, no, that's not right. Okay. 8 minus 4, 4. 7 minus 0, 0. 5 minus 5, 0. Or 7, sorry. Did I type it in wrong? Negative 133 divided by 470. And I multiply that by 81. (21) minus a negative 22 should have added up to 43 divided by 7. I don't know where the mistake is. That's unfortunate. All right, I'm just going to pretend that that's right so I can show you the rest of this process, but I know it's wrong. So B here is equal to 6.274. I know that this should be like something like 7.11 something. I've done this problem in the past, and I'm just remembering that number. So let's go ahead and assume that that is the correct answer, which it's not. So we have A, we have B. So in this equation, we have A, we have B. We just need to solve for C. So what do? We plug into any of this equation, or this equation. You look the easiest, so I'm going to go ahead and say, rewrite that. I'm going to have 11 is equal to 9A plus 3B plus C. So what's our A? Our A is that disgusting, I don't have enough room here, negative 133 over 470. Our B is that decimal, 6.274. 6.274. And you just solve for C, right? So you can say, okay, this is going to be 11 is equal to 9 times negative 133 divided by 470 is going to be negative 2.547 plus, okay, then what's 3 times 6.274? That's 18.822 plus C. I'm going to add together those last two answers. So I'm going to go second enter, second enter, second enter, second enter, second enter. So that number plus 18.822, and it's that. And then I'm going to say this now. 11 is equal to 16.275 plus C. And then finally subtract the 16. So I'm going to say 11 minus the answer, and I get negative 5.275 is equal to our C, which means we have our answer, right? We have our A, B, and C. We can say that, let's move this out of the way. It's kind of anticlimactic because I know that I made a mistake, which is frustrating, believe me. So I know that my original equation was C of T. C of T? Yeah, it was C of T was going to be ax squared plus bx plus c, and a, we now know, is, I'm just going to make it a decimal, negative 133 divided by 470 is, c of t is equal to negative 0.283 x squared plus bx, b in this case is 6.274, then plus c, which is actually a minus 5.275. Man, that was a long problem. Here's how you do that entire 20-minute process in like 10 seconds. You go and you enter the data into a table. You go enter, we're going to clear this. We're going to go over here, we're going to clear this. I guess it takes a little bit of time if you haven't cleared it. And then you just enter 3, 10, 15. Let the calculator do the lifting. 11, 32, 28. And then from here, we're going to do a stat, go to the right to calculate, and we're going to calculate a quadratic regression. So hit 5, and we're basically done. We're going to store the answer in, sorry about that. We're going to store the answer in alpha trace y1. And there it is. Yeah, I knew that I made a mistake. I did all that work and I didn't even get it right. All right, so I can see that my A value was not negative 0.283, it was negative 0.317. I don't know where my mistake is. I'm kind of tired from doing this video all in a row, but that's how you do it with the calculator. I'll come back later and change this problem and probably re-record this whole video. We'll see. Anyway, let's move on to the next part, which is B. B, use the given data to find the average rate of change in the number of customers on hold in customers per minute from 3 to 10. Well, this is something that's super easy to do. Average rate of change that to the word slope. It's asking us to find the slope of the customers between 3 and 10. So between 3 and 10, how do we find the slope of those points? In general, slope is always going to be, I want to change my color. Whoa, didn't mean to do that. Slope is always going to be the change in y over the change in x. So how much did the, and I guess in this case it's the change in c over the change in t for our purposes. The change in c, well, I had 32, and I started at 11. To get the change in t, I had 10, starting from 3. So this is going to be 21 over 7, which is just 3. Done. And then part 2, use that average rate of change that we just found to estimate the number of customers when t is equal to 6. There's a few ways to do this. My favorite way to do this is using the point slope formula. So if you know point slope formula, I'll write this down. Point slope formula. It's y is equal to the y coordinate plus the slope times the x minus the x coordinate. In this case, y is going to be equal to, we're going to use 3 and 11 here. So the y coordinate here is 11 plus the slope that we just found in the last problem, which is 3. X minus the x coordinate, which in this case is 3. There is our equation. And we can use that to predict anything we want. We want to predict when t is equal to 6. So we're going to say here y is equal to 11 plus 3 times 6 minus 3. And doing some mental math, this is going to be y is equal to 11 plus 3 times 3, which is going to be y is equal to 11 plus 9, which is going to be y is equal to 20. All right, and then part 3. Consider the average rates of change from 10 to somewhere else, in between 10 and 15. So I'm now doing kind of the same thing. Slope from here to here. Are these average rates of change less than or greater than the average rates of change between 3 and 10? Explain our reasoning. So if I'm looking at my table, let's actually see this one nice and big. I know that the slope to get, and again, these are the windows from x, but really I'm going from, let me get rid of all this stuff. Really I'm going from 11 to 32. What is my rate? My rate is 3. My slope is 3. Now it's asking, hey, I'm going from 32 and I'm moving to the right. I'm not going to end at 15, but I know I'm heading towards 28. Which is bigger, this number or this bigger? What's the rate? Who wins? Well, think about it. 11 goes up to 32 and 32 goes down to get to 28. So which one is bigger? The positive one is bigger because this one has to be a negative number. And that's just like a logical question, right? So what I can say here is that is asking which one is larger, which one is smaller. It's asking, is it less than or greater than? So we'll say that the average rate of change, we'll use their terminology, the average rate of change between time is equal to 10 and time is equal to whenever they decided t is equal to k, I guess, is less than 3. Why? Because it has to be negative. And a negative is less than 3. All right, next, what do we got? Part C. Last question, we're done. A local cable company wanted to use the Model C to make predictions about the number of customers beyond 15 minutes. The Model C is an appropriate model if predicted number of customers on hold is non-negative. Based on the information, what is the largest integer value of t for which the Model C is an appropriate model? So what we need to do is we need to use our incorrect equation and figure out where it hits 0. Because essentially what's happening here is we have a graph, right? We have a graph that's saying, go, and then like it doesn't make sense to have a negative number of customers on hold. It's asking, okay, where do we cut this function off so that it's considered a real function? Because that would be the fake function. We can't have a negative number of people on hold. So try to find that value. I have no idea how you would do this without a calculator, if I'm being honest. You could test in points, but we're totally just going to use a calculator. So this is what we're going to do. We're going to come back to our calculator, which has the correct equation entered, and I'm going to move you to the left so I can actually see what's going on here. And I know, is there any rough ending time? I don't know. I mean, according to my table, it's going to be somewhere after 15, so let's be safe. Let's just do 20. It'll probably hit 0 by then, right? So let's go ahead and do a window between 0 and 20. And then we're going to zoom 0 this thing. Okay, we're off a little bit. So let's do window. Let's go to 25 and zoom 0 it. There it is. Okay, so it finally hit the 0. It looks like it's about 22. So I'm going to do second trace to calculate the 0. So 2. I'm going to say my left bound is 20. My right bound is 24. And this value right here where it crosses the t-axis, I suppose, is 21.365. So the question originally was asking us, where do we cut off this function in order to have this correct, right? So we said, what is its largest integer value. Okay, so largest integer value means that largest integer value is 21, because if we go to 22, then 22 is going to be down here and it's going to be negative. 21 is probably right about here, and that's fine. And it does tell you to give a reason for your answer, and we can say because 21.365 is 0 customers, and 22 would be negative customers. Excellent. Well, that was a long and very challenging video to do. I am still frustrated by that part here. That concludes the video, guys. Thanks for watching.